This Christmas, my little girl received some Orbeez for, I guess, a foot spa that she has. So I have these down here, different colors, blue, yellow, orange, and red, and these two yellow ones are supposed to be the same size, but they're not. But treat them as if they are, and treat them as if each ball represents 1 mole. So we're going to go macro. We're not going to talk micro, AMU. We're going to talk macro and treat each ball as 1 mole. 6.02 times 10 to the 23rd of whatever that item is. So in this case, molecules that are reacting are compounds, since there are two different atoms together, compounds, molecule of O2 and water and CO2. We're trying to balance an equation, but again, we're thinking macro. We're thinking in terms of moles, not in terms of 1 C2H2 plus 1 O2 makes water and CO2. We're thinking big, so we're thinking moles, but we still have to balance. So we notice right away that if you look at the number of carbons on the left side and the carbons on the right side of our equation, our reaction, we have a difference, 2 and 1. So I'm going to go ahead and try and balance the carbons and see if I can get that right. And I'm always going to do the last one as oxygen, or whatever is in the molecular form is only one type of atom, because that's going to be the easiest one to clean things up with. So I'm going to put a 2 here. That gets the count right. 2 carbons, 2 carbons. I notice that I add up the oxygens. 2 times 2 is 4, plus 1 is 5. And I only have, I guess, an implied 1 here. So what I'm going to do for now is put 2.5. 2.5. Now I can't have 2.5 because that's a fraction of a O2 a mole amount, or you can't cut it in. You have to have whole numbers. So what we're going to do is just double everything. So we're going to double all the coefficients. So an implied 1 here, oh, I forgot to check H2 just to make sure that that was equal on both sides, and it is. So we have H2O, C2H2. So the number of H's checked to 2. We had oxygens right now at 5 on both sides. 2.5 times 2 is 5. And carbons we have at 2. But it's not going to work because it can't have 2.5. So I double all. So 1 times 2 is 2. 2 times 2.5 is 5. 2 times 1 is 2. 2 times 2 is 4. So now we can bring everything down. I'm just bringing this down, and we have now a balanced equation. Just to kind of bring back a little bit of what this represents, I've got my balls here, and I'll finish with this. We can say, okay, what we're really saying is we've got 2 moles of C2H2. C2H2 actually looks like this as a compound, a covalent compound. We have 2 moles of this. We're combining with oxygen. Got my 5, my Orbeez are falling apart, but I'm going to roll those up. And we have 5 moles. And what we're saying is if we were to react these 2 moles of acetylene, or C2H2, with 5 moles of O2, 1, 2, 3, 4, 5, we would get, if we do that reaction, 2 moles of water, and we would get 4 moles of CO2. And again, we're talking macro moles. It is also reflective of the molecular. We could say, yes, it is moles that we're talking about. 2 moles plus 5 moles gives 2 moles of water and 4 moles of CO2. But we can also think micro, kind of number of molecules, compounds. 2 molecules of C2H2, 5 molecules of O2, 2 molecules of H2O, and 4 molecules of CO2. But you have to be able to work with moles, because in the lab we have to work with grams. That's a pretty good picture, I hope, of balancing an equation and how to think of it in terms of moles. Each ball represented a mole amount of each of these compounds. Bye-bye.